Transactional control. What is transactional control in a relational database? It's a way of grouping commands together as storable or undoable commands as a set. So you can have 3 insert statements and you can commit them all at once, or you can roll them all back at once. What is a transaction? A transaction is a group of commands that can be saved or removed. Transaction control commands allowing control of transactions include the commit command, where you write data to the database, the rollback command, where you undo data to the database, which is effectively writing it back again because the commit's already written it, a rollback command where you effectively rewrite the changes back into the database to undo them, because commit actually doesn't write changes to the database, it merely says that the changes that have been written can stay there. A save point is a special go-to label that allows you to go back to a point where a set of transactions can be saved within that set. So if you have 3 inserts, you can go back to the save point on the first one, save the first one, and undo the second 2. We'll see that in an example later on. So a save point defines a label, such as a go-to, and then you say roll back to that save point. So undo to the point, or back to the point where you have the save point defined. So you roll back or undo changes back to the label. Set transaction is a way where you can set the parameters or the configuration of a transaction during the life of a transaction. You can set it to read write or read commit it, which are the default values. When it's read committed, the transaction waits for a lock to be released before completing. It's isolated. Serializable means it's one after the other. Do not wait for locks. Transaction fails immediately on encountering a lock. Read committed waits for the lock to be released. Large transactions can be allocated explicitly to large rollback or undo segments. Locking changes allows you to work with the visibility of data, which does incidentally happen automatically, because where session 1 changes information, session 2 doesn't see it until session 1 has committed that change, and vice versa. But you can manually lock data inside one session so that the second session cannot work with it until you physically unlock it. That can get a little dangerous because you can lock a tremendous amount of data that if a lot of other sessions are trying to access that large chunk of data, you can lock an entire database up. Be careful using that type of command. You can lock in sessions and you can lock entire tables. Commit and rollback, what do? Well, generally a commit is faster. Why? Because it's executed much more often. Mostly. I've never seen a database that has far more rollbacks than commits. Generally, you would think that you're actually making positive changes rather than undoing mistakes all the time. Even in financial systems where you have undo commands, they're actually called reversals. What you do is you create a duplicate transaction in an accounting system or a financial system. It's called a reversal transaction, and it's an extra transaction. You do not remove the original transaction that deleted something for the simple reason that it needs to be stored as a record. So it's a log. So rollbacks are rare. Hopefully. Why? Well, mainly because a commit is much faster. Rollbacks are much slower for the simple reason that rollbacks do a lot more work all at once. So hopefully rollbacks are less frequent. So what happens with commits and rollbacks? Very important to understand this. It's very basic, but it is important to understand it. So when data is changed, as you can see down here, I have rollback data, redo logs, and a database. So when I change something, I insert, I update, delete, whatever I do. I haven't executed a commit or a rollback. The database is actually changed. It changes the database, regardless of whether commit or rollback has been altered or however many transactions you have in a transaction block. The logs are also written to. Why? Because if you want to redo something or recover the database because it fails, the way it recovers it is by reading the redo logs, so they have to be written straight away as well. The rollback is written third. What happens when you commit? Everything's already been changed. You've written your database, you've written your redo logs, and you've created your rollback in case you want to undo it. So what do? You just delete the rollback. You don't need it anymore. In fact, it doesn't even delete it. It goes into the rollback section and just flags it. It says you don't need to worry about that anymore. You can just override it, which is exactly what happens in a low-level disk. When you roll back, your database and your redo logs are already changed, so you need to reapply the changes backwards to the database. So you read the rollback, you write to the database, and you actually record the rollback undo changes in the redo logs. So you change the redo logs first and then you change them back. Remember I was talking about reversal transactions? It's the same thing. Finally, the rollback is deleted or simply flagged as overridable. So on commit, remember, only rollback is deleted. On rollback, rollback is applied to the database, reapply the changes, rewrite the redo logs, remove the rollback by deletion. Commit is a lot faster. It's meant to be. That's the way it works. So as you can see here, when you execute SQL commands and no commit and rollback is applied, you write everything. On commit, you simply delete the rollback. Everything's there already. On rollback, you've got to read the rollback, you've got to write the logs, you write the database, you've got to undo the rollback, so on and so forth. Much slower. You want to be committing a lot more than you're rolling back. Much more efficient.